it's basically the same question with the same equations, but I kept doing a lot of math, but I never came out with the right answer.
Okay.
And it was like a question that was, one of the equations was like,
Yeah, do you remember them?
yeah. They kept giving me the same equations. It was the QD was equal to 105 minus 1.5 P.
Okay.
And then QS was equal to 1.5873 and T minus 15.873.
Okay.
And then those were basically the same equations that they kept giving me. And then for the inverse demand, I got P equals
What were you asked to solve?
it gave you a tax of $20 for each tire. So I put I added it to
So $20.
yeah.
Okay. And then it asked you to do what? To solve for the
Yeah.
quantity or what?
Consumer surplus after.
Consumer surplus after the tax. Okay. And you guys did anybody get this one? So it's maybe an error in the answer key possibly?
I just didn't understand it. Like it threw in like, one of the questions threw in like a 0.375% blah, 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 or something like that at the beginning, and that kind of threw me off. Like I wrote them down those, but I solved like a subsidy, I guess.
Uh-huh.
That may have been one of the questions, I'm not really sure. It's a bunch of random numbers written down.
Okay. But this was a tax question. Okay. Well, let's work through this one. This looks fine. Yeah, good place to start. So, what'd you do first?
Found out the price. Just set
the-
it equal to each
The inverse. Oh, you solved for the equilibrium price first.
Well, the inverse, actually I found the inverse.
What were you asking? What did the question ask for? Was it the new consumer surplus after the tax?
This was just one of them, because I have it all like scratched out, but just one of them was, they gave you a $20 tax and they said find consumer surplus after.
After the tax. Okay, so I mean, I think what I'd maybe do mentally first is just do kind of this and say, what am I looking for? So I got PC, the price that the producer pays, the price the consumer pays. I'm looking for this right here, right? So we wouldn't have to like go through the trouble of solving for the equilibrium here. We really don't need it for this particular problem, because all we need to find is this price, this quantity, and the choke price. So if I solve for the inverse demand curve, what do I get here? 1.5 P equals 105 minus Q. And P, can you guys pull out your calculators, help out here? 105 divided by 1.5. How much?
70.
70, okay. And negative 2/3. Okay, so we got 70 for a choke, right? And now we are going to need to implement the tax. So, how'd you do that?
I added 20 to the supply.
Okay. This supply function, so we'll just add 20 on here?
Yeah, because that's the only way I guessed how to do it, because that's how we did it in
Yeah.
the Coca-Cola.
That's fine, but it's not right to just go add 20 right now onto this.
No, I'm trying to shift the supply curve on the graph up to that point.
Yeah,
So you have to go
to the inverse supply curve. Yep, so you can't do that. You need to solve for the inverse supply curve first. So now we've got an inverse supply of 1.5873 P equals QS plus 15.873. P equals, and then help me out here,
It's like 0.663, and then
QS, okay? And then plus 10, okay? And now we can add that 20 onto this equation,
not 0.663, just 0.63.
0.63. All right. And then now we can add that 20 on for the tax. So this is the inverse supply function, and with the tax, we get P equals 0.63 QS plus 30. And now set this one equal to this one.
For the choke price,
So set equation, there we go, one sec, Jesse. Let's call this equation 1 and this equation 2. Set 1 equal to 2.
to find that choke price that you said you have 70 with,
Uh-huh.
wouldn't you have just set that equal to 0?
You can. You could set quantity equal to 0 up here, and then 1.5p equals 105, because that ends up being 0. 105 divided by 1.5 equals 70.
Or you can look at the inverse and just take the intercept.
The intercept, yep.
Gotcha, okay.
So technically, we're going to need this equation to set them equal to each other later. So I would tend to just do that anyway. There might be circumstances where you just need the intercept, and then that would be fine too. All right, so what do we get then? We got 0.63 quantity plus 30 is the supply curve equal to the demand curve of 70 minus 0.667 Q. Solve for Q. What'd you guys get? You guys just catching up here, or what are you doing? Talk to me. I don't have my calculator.
You're on 31 rounded.
How much? 31? And don't, tend not to round, go ahead and give me like out to 2 digits.
31.96.
One reason is that this might be measured in thousands. I don't know if this problem had it or not, but if it's measured in thousands, then you can kind of remember that's really either 31,960 units or 3,196 units or whatever, so.
It's actually 30, not
30, okay. Okay, so
It was, yeah, when it,
was that one of the answers?
the question was, no, that wasn't one of the answers. I was just gonna say that when the question answered it, it says it was measured in millions.
Oh, it was measured in millions, okay. So this is 30 million units, okay? So then we're down to, we've got 30.96, and we've got our price after the consumer we haven't solved for yet. What does that equal to? Anybody do that yet? So you need to go back into the demand equation, right? Because the inverse demand, now we're plugging this quantity into that inverse demand curve to get that price.
You said plug that back in.
Yep, because is it's this quantity, so now we're gonna shove it back into the inverse demand curve to get that price PC. So we're gonna substitute that back into equation 1, the inverse demand curve. 49.35. Everybody get that? I don't know the answer, so I'm relying on you guys by consensus. Okay. 49.35. Question asked for consumer surplus, so now we're back to 1/2 base times height. 1/2 of the base, which is 30.96, times the height of 70 minus 49.35. And what do we get?
319.60.
And then this is actually in millions, so it'd be 319 million.
Just 0.66.
66. Oh, 0.66, not 1/6. Everybody else get that?
Yeah.
Pretty close. Alright, so did you mess up something in between on this path, or do you think the answer was possibly not there?
I kind of figured out
Okay.
what I did. It's hard to
Which one of those
remember.
where you typed in the answer?
Yeah.
Oh, okay. Yeah, I'm not sure. I think when I read somewhere, they have some rounding, like if you get into that range, they give you the right answer, I think, but not positive, so.
And if you don't answer it within the next 2 seconds, it says, "Do you need further help on this?"
With the hint thing,
Yeah.
and you can tag the hint. And,
There's
yeah, this one would take longer than 3 seconds to
Yeah,
do
it's just
that.
funny.
You step on too quick too, then it tells you I think you can longer.
Oh my gosh.
All right, good. Anything else on ones from the homework or?
If I remember, I'll have the question.
Okay, so yeah, another point is I'm willing to go through these just like in great detail like this. So you guys do them. If you're messed up on it, jot a note to yourself, and then the next day for class we can take some time to go through them.
So for the test, are we gonna need to know how to calculate debit and loss?
Yes, possibly. Any of these problems it's all fair game. And doing it by hand. That's why you need, when you work these problems, work them through by hand on the sheet. I'm going to do some additional problems as well as part of your homework in preparation for the test too, to get some more practice.
So is like the majority of this class is going to be, or the majority of the tests rather are going to be problems?
Mhm.
Going to work?
Well, yeah, and I'd mix in some multiple choice too. Yeah. But I'll probably I didn't have this online resource last time, so I'll probably do some of the multiple choice through the online resource and then in class more other problems. All right. So we started tackling consumer preferences last time, and you mentioned subsidy. Were you guys okay with the subsidy thing? I didn't go through a problem on subsidy.
I got stuck.
Okay. I just want to point out, I guess, one thing. I can go further if you want, but on that problem, we could have said, let's subsidize it $20. And now that I erased all the equations, with the subsidy, I would again go back to this kind of picture, and it floats in from the other side. So if we're subsidizing student loans or whatever, we told some of those stories before. So we're gonna add $20 to the consumers. So then all you're gonna do is on the inverse demand curve, add 20. And then you could subtract 20. Again, it doesn't matter which way you do it, but the amount of the subsidy is there. So then you're kind of mathing it all out the same way. The top part of the wedge touches the supply curve, so that's the one thing that's a little different. Remember that the producer effectively gets more, a higher price after the subsidy, and the consumer pays a lower price. We're trying to encourage the activity. The quantity after the subsidy is greater than where we were in a free market. So the rest of the math kind of just flows out if you've got the pieces to the puzzle. Now, calculating consumer surplus, which is a little bit different.
Would that be the bottom triangle thing?
Yep. So kind of
All the way to that.
all the way to here, all the way to the amount that they're actually consuming. So with the subsidy, they're consuming 120 units. They used to be consuming 100, let's say. And so the consumers now are paying $3. Producers are getting $5. I'm just making up some numbers. So the subsidy per unit is $2. And I think the textbook has pictures and stuff on that too. So the new consumer surplus is this area. And if you pull out your old principals notes too, that we spent a lot of time kind of doing the areas. The producer surplus is this area. They overlap. Because the producer's getting $5, the difference between what they're willing to pay, what they actually get, and the minimum they must get.
And if that little triangle to the right, that we lost then?
Yes, this ends up being the deadweight loss at the end of the day. If you start subtracting out, you bring the government into the picture because the government is spending this much in revenue.
So in turn, you really don't need to see the dotted new demand curve or whatever. It really doesn't affect.
Right. It just sets the difference between where the prices
It
are
just
going.
kind of gives you.
Yeah. And I didn't put it on here, but the producer used to have, of course, that triangle. And so now they're producing this much and getting a price of 5. Okay. So fall back to the definitions. The difference between what you're willing to pay and what you actually pay for each unit you consume is the definition we did on the board for consumer surplus. Producer surplus is for each unit that you consume. And for the producers, it's the difference between what you actually get for your product and the minimum amount you must get, which is the supply curve, which is the marginal cost curve. All right, so that's a quick snapshot of a subsidy, but then you got to fill in, use the appropriate inverse functions and kind of work the problem just like we just did. All right, any questions there? All right, so we're gonna throw ourselves right into the mix with the consumers today and spend some time on that. So if you look at question the 4.1, Mariah consumes music downloads M and concert tickets C. Her utility function is given by that, where the marginal utility of music downloads is equal to M, and the marginal utility of concert tickets is equal to 4C. So those are functions now. This is, you know, we talked about the marginal utility of pizza and beer when we did principles class, and I said the marginal utility of the fourth beer is 15 units of satisfaction. And now the marginal utility of music downloads is equal to M, meaning if you're doing 4 downloads, the marginal utility is 4. If you're doing 5 downloads, the marginal utility is 5, so it's a function. So write an equation for the marginal rate of substitution of M and C. MC, marginal rate of substitution. Does anybody have a vague clue of what that sucker was? How about even conceptually? I gotta be honest with you, I'm not expecting you to remember that. So, all right. Now, we gave the 4 axioms of choice last time, thinking about consumers' preferences. And I showed you those 2 pictures that I think is helpful to keep in mind. We've got one picture where if we're measuring the total utility of music downloads or pizza, let me just keep this a little bit back on a different topic here. Let's go with pizza. That utility function would look something like this, which shouldn't have this little wiggle in between, but kind of a little cave looking thing. So that's what total, why does it have that shape? What law? Diminishing returns, diminishing utility. So as I eat more and more pizza, the value that I get from each additional pizza diminishes. Okay, so the graph over here to the right is in 2-dimensional space with 2 goods. And so if we have the quantity of beer and the quantity of pizza being measured, we can think about how utility relates in the 2-dimensional space. Ideally, we'd have a 3-dimensional picture. So we'd have a or a beer axis shooting somewhere off here into the distance, and we could kind of look at the shape of the utility function in a 3-dimensional space. And so for the 3-dimensional creature, this one works out pretty good. Remember, we're going to measure total utility along this axis, and maybe each brick ends up being 10 units of satisfaction, right? So our meter's going up as we go 10 units, and then we've got a beer axis and a pizza axis running along the corners. And if we were to look at this 3-dimensional thing, it would start off at the origin where all the axes meet, of course, where there's 0 of everything, 0 beer, 0 pizza, and 0 satisfaction from those 2. And then if we looked at it, this thing would come up over the class like a big canopy, kind of generally looking like this kind of thought, but it would kind of come up like a big cave, a big cape. And then if we took our samurai sword out and froze the utility at 100 units of satisfaction, and I cut into the cape, and I took that slice and I dropped it straight to the floor, what that shape would look like is this. And that's our indifference curve. So that's a slice of the utility function dropped straight down to the floor. Along this slice, the utility is held constant at 100. So let's just call it I100. Look back how the textbook does notation. Try to stay consistent with that U. They call them U's. Okay, so instead of, they're called indifference curves, but we're just going to put a U for utility. So along this indifference curve, utility is held fixed at 100. And the shape of this is, from a math standpoint, is called it's convex to the origin, so it's bowed the way it's bowed. When we have a cave look to it, if a function looks like this, it's concave to the origin. So you might see that terminology in your text. It's no big deal. It's just describing the curvature away from the origin. So we say that that's convex to the origin. And this is the shape that obeys the 4 axioms of preference that we had before. Law of diminishing utility is captured by the slope changing as we move from point A to B to C. And the slope captured by the slope of a tangent line at that point shows a less beer being willing to be traded off for the additional units of pizza. So if we're sitting out here at point C, we've got a lot of pizza and we're a little skinny on beer, right? So I've only got a couple beers and I've got 100 pizzas. So if you ask me a question as a consumer and say, hey, what do you think, how many beers are you willing to give up for the 101st pizza? You're like, whoa, man, I only got 2 left, dude. I'm not going to do it. You know, up here it was a little different, where we were getting a little hungry because we only had 10 pizzas and we had 24 cans of beer, so we had a case of beer going. We're like, man, I could really use a pizza. I'm willing to give up a whole bunch of beer to get a little bit of pizza because it's just a few pizzas at this point. That's the marginal rate of substitution. Your internal, as a human being, your trade-offs that you make depending on the scarcity of the goods. If you're sitting fat with one good and skinny on the other, then your trade-offs are different than when you're sitting fat with the other good and skinny with the other, right? So that internal trade-off reflects your personal preferences, and that is the indifference curve. And so the first axiom that we had on completeness meant that you're able to tell us those trade-offs all along various combinations of beer and pizza. That's what the completeness part of the preferences were, that we have a nice continuous function that illustrates those preferences, and they behave well, that we don't get to a weird spot here, like if there's diminishing utility, as we get here, all of a sudden we change our mind and like we're really jonesing for more beer or something, you know, that it looks wacky, that it kind of does this as we go around. So those 4 axioms kind of give way to the shape of the basic indifference curve. So the slope of the indifference curves at a point, the slope is the marginal rate of substitution. So the marginal rate of substitution MRS try to stay consistent with like the book words it out for you. So the MRS of, like, we'll just go straight with good X and Y here. The rate at which a consumer is willing to trade off one good the horizontal axis good in parentheses, kind of like that they give it to you this way, for another good. The vertical axis. Good. And still be left equally well off. In other words, utility is held constant. So, if we were looking at a picture of yo-yos and x-rays, and we had a indifference curve of utility level equal to 10, the slope of this line is the change in y over the change in x. So the marginal rate of substitution of good x for y ends up being related to utility at the margin. And it's the marginal utility of good x over the marginal utility of good y. Now, back to principles class. What is the marginal utility of x-rays? What does that look like from a formula standpoint, I guess? You're looking at the marginal utility of x-rays, the marginal utility of pizza, the marginal utility of beer. How would you express that in a formula? Or verbally? The marginal utility of beer.
How much satisfaction you get from one additional unit?
Good. Okay, so the change in satisfaction, how much satisfaction you're getting from that extra unit. That's the type of verbiage you want to use. So if we were looking at, I guess this has got pizza. What have I got? Two different things going? What's this? Oh, that was my beer axis when I went 3 dimensions on this. So back to just 2 dimensions for a second. If I'm at the 100th, 100 pizzas versus 101, the 101st pizza gave me this much extra satisfaction. So the change in utility would be represented by a little delta, the change in total utility from the change in the amount of x-rays divided by the change in total utility from the change in the amount of yo-yos. Fraction in the denominator, invert it, multiply it times the numerator. These two cancel out with each other. This is the way I always kind of think. You're going to likely get stuck on this again, so this is how I usually have thought of it. Change in total utility over change in x times change in y over the change in total utility. I hate my little board right about now. I want to write on the concrete block. These two cancel each other out. Rise over run. Change in y over change in x. We're into that space. So, pay special attention to the notation. Marginal rate of substitution of good x for y means the marginal utility of the x variable is on top. The marginal utility of the y variable is down on the bottom. Memorize that. It is counterintuitive to what you're thinking rise over run. Rise over run has the y on top and the x on the bottom, which is just opposite of what's going on here. And this is the reason. You can go back and tell yourself that story. It all works out in the end to be the slope. Questions on that? Well, you're going to get some practice right now. Back to our 4.1 with that little backstory. Write an equation for the marginal rate of substitution of music downloads and concert tickets. So, think out loud this time. What are you doing? Okay. What equations?
The marginal utility.
Okay. So what goes on top of music? Good. So do that. Okay. Would bundles of 4 and 1 and 2 and 2 be on the same indifference curve? How would you go about calculating that? So we're getting 2 points. Would 4 and 1 and 2 and 2 be on the same indifference curve? So imagine we've got our music here, concert tickets there. We've got a bundle of 4 and 1 and 2 and 2. Those 2 points. Would those bundles be on the same indifference curve? No? How do you know?
Well, because marginal rate of substitution should be the slope of that line.
Okay.
And the slope between those 2 points is not that.
Got to be careful because we don't know about the shape for sure of the indifference map.
Would you plug them into the utility equation and then just if the 2 points?
Yep, that's it. Do it. So you've got the utility function. Plug those points into it. This is where having I guess a little more than a basic calculator is nice if you can do some exponents. Why don't we have Did all of you start on 4-1? The bundle 4 and 1? Okay, why don't you just jump on 2 and, are you done with that one? Did you do both of them already? Okay, what'd you get? 10. Sounds good. 10 for both? On the same indifference curve then?
Yep.
Yes. All right, so, Adam, you all right with that?
Yeah, I'll just write it down and
Okay. So, both points. So yes, both have utility equal to 10. So that means there is an indifference curve. Not sure exactly what its shape is, but there is some indifference curve that's equal to 10. All right, calculate the marginal, so part C, calculate the marginal rate of substitution when m equals 4 and c equals 1, and when m equals 2 and c equals 2. So now we're going back to the MRS calculation. So we're trying to get this slope at these points, right? As soon as you get an answer, I should have had you guys split up maybe and do, what'd you get?
1 for 4 and 1.
Okay, 4 and 1. Got a 1, positive or negative? Positive? It's negative?
It looks negative.
Kind of looks like it's negative. All right, slope of 1. You got what? 1/4. Okay. So how do we deal with that? So part D kind of falls into this. So based on your answers to B, are Mariah's indifference curves convex? Slope of 4, slope of 1. So at that point, I kind of misled you a little bit intentionally by putting the traditional look here. But what I want you to think about is not knowing what the indifference curve actually looks like. Let's just pretend we don't know Mariah's preferences. All we've got is this data. And so how does her indifference curve really look? Slope of 1/4 versus slope of 1. So which one's steeper? Which point is steeper? Let's, I guess, call this, which one were we getting first? I'm going to put A's and B's, 4, 1. So let's call this point A and point B. So what's going on at point A? It's steeper, right? So a 1-to-1 slope would look like this, let's say. And 1/4, rise over run, look like this. So that is if her function is continuous and curved, which this type of function would be. What's it looking like? Is it convex? Yeah, it bows outward,
So,
which means she's not obeying our axioms of preferences. Go ahead, Taylor.
so based on those lines, this slope should be negative.
Yes,
So then-
it is still negative, but her indifference curves would look like that, which means she's not normal.
So then did we calculate the slopes wrong?
No, we calculated everything right. This is just a weirdo situation. So what the textbook was trying to highlight for you was taking a problem with some functional forms and showing that not all functional forms will give you the results that we're looking for. And that's how we test for it. So if we were to say, does Mariah, which is basically what they say, right? Well, it doesn't say it, but are Mariah's indifference curves convex? Another way of wording that would be, are Mariah's preferences in line with the 4 axioms of preference? And the answer would be no, because her indifference curves look like this, which don't make sense. It doesn't follow the law of diminishing marginal utility. All right, so D would be, are they convex? No. Mariah is a weirdo. Mariah is an outlier. She's irrational. She's crazy, according to the economist's assumptions. Okay, so any last questions on that one? We're going to do some more practice, so if you're still foggy, but if there's anything here. So if you flip it over, let's look at this one here. Braden has $20 per week that he can spend on video game rentals priced at $5 per game and candy bars priced at $1. Write an equation for Braden's budget constraint and draw it on a graph that has video game rentals on the horizontal axis. Be sure to show both intercepts and the slope of the budget constraint. Okay, getting fun here. Now we're into a budget problem. So we wrote out the budget constraint, I think last time. If we are back to, I guess, we'll do x-rays and yo-yos. So I've got a certain amount of income. I've got the price of good X times the quantity of good X plus the price of good Y times the quantity of good Y. And this is my total spending on x-rays and yo-yos. If I draw yo-yos on the vertical axis and x-rays on the horizontal axis, what does this equation look like? What do I need to do to manipulate this to graph it, to kind of mesh up with a graph that has y here? Yeah, so solve for y, right? So get y all by itself on one side of the equation. So if you do that, I'll do it in a couple steps here, but you guys can start doing it on your own. You should have income minus quantities of good x, or the quantity of good y is equal to I over py minus px over py times qx. Well, that's kind of convenient. What form of an equation is that? Slope-intercept form. So now you've got q over here, the y variable, that vertical axis variable, equal to an intercept, which is an amount of money. If you've got $100 and yo-yos run $10 a piece, you can buy 10 of them, right? So that'll be the quantity of yo-yos I can buy if I blow all my income on yo-yos. That's what the vertical intercept ends up being. So that's the intercept. And then this is the slope. And we'll pick up there on Wednesday.